Continuing our example, we are now going to fill out the entries in the matrix A squared minus D, where D is the degree matrix. Now the degree matrix is the matrix consisting of the degree of each of the vertices. So you have degree down the diagonal and 0 everywhere else. And remember what we found in graph theory 3 was that down the diagonal of A squared is the degree of the vertex. So in the matrix A squared, let's get rid of the D for right now. In the matrix A squared, we have the degrees down the diagonal, right? These are the degrees of each of the vertices down the diagonal. So when we look at A squared minus D, what happens is we're just taking away all of the degrees down the diagonal. And so essentially, when we fill in this matrix A squared minus D, we have zeros down the diagonal. And so when you do this part, even if you don't really understand what I just said, no big deal, you can just put zeros down the diagonal. All right, now let's figure out some of these other entries. Remember that A squared, that each of the entries in A squared is the number of two-edge walks from a vertex, from one vertex to another. So let's start with this entry right here, the W1, W2 entry. So first, what I'm going to do before I find all of these two-edge walks from W1 to W2, I'm going to draw in blue here. Here's the possible edges our two-edge walk could go across, starting from W1. And now W2, let me draw the edges that touch W2 here, like that. So let's see, how many two-edge walks are there from W1 to W2? Well, we can see one of them right here, going there and there. That's one two-edge walk from W1 to W2. And here's another one. Going from W1 to W2. So we have two edge walks from W1 to W2. Using symmetry, we know there's a 2 there as well. There's two edge walks from W2 to W1. Now moving along, let's say W1 to W3. Again, I'll draw in those there. And W3, we have that there. So you can see there's only one two-edge walk from W1 to W3. That one. W1 to W4. Now don't worry, I'm not going to make a video where I fill out every single entry in this matrix. I'm going to fill out all the ones along this row. I'll fill out a few down here, probably just these in here. And then I'll explain why a lot of the entries are going to be 0. And so when you fill out yours, you'll immediately know those are going to be 0. And then I'll tie some concepts together. Okay, so let me just finish out this row. And finishing out this row, you'll see a nice way to go about doing this problem yourself when you do the problem yourself. All right, so W1 again. There. W4 there. So you can see just one 2-edge walk from W1 to W4. W1 to W5. Just one there, you can see. W1 to W6. Let's draw on the edges for W6. Okay, just one there. W1 to W7. There's none there. W1 to W8, there's none there. All right, now let's think W1 to S1. Now there is an edge from W1 to S1, but now think about 2 edge walks. One possible way from getting to from W1 to S1, right? There's one edge, but now we need another edge. Any other edge is going to take us back over. Do you see that? And now to get back, we're going to need 3 edges. So there's no 2-edge walks from a word to a sentence. It's just not possible. And so because of that fact, we know that all of this will be a 0 block. And similarly, there are no 2-edge walks from a sentence to a word. And so this whole part will be 0. All right, now let's look at this row right here, this entry, and then these couple of entries here. So first we have S2, S1. Or S1, S2, S1. So S2, S1, let's take S2 and we'll draw in its edges. And then we'll look at S1 and we'll draw in its edges. 1, 2, 3, 4. And you think, okay, is there any way that we can connect those? S2, S1, let's see, none there, but there are 2 there. So there are 2 edge walks from S2 to S1. Let's see, S2 to S3, so that right there, S2 to S3, S2 to S3, 1, 2, 3 edges there. And now do we have any connections? Let's see, there's S2 to S3, we have that one, and S2 to S3, we have that one. So there's 2 of those again, so 2 there. And now S2 to S4. And you can see that there is one of those. So now what you would do is you would fill out the rest of these, right? You would say, okay, W2 to W3 to fill out that one in exactly the same way we did all the other ones above it. And then you really don't need to fill all of them out because of symmetry. So let's say let's look at W5, W1 here. W5, W1, right? Well, see, W1, W5 is a 1. So W5, W1 is a 1, right? So that's symmetry. So using symmetry like that, once we get all of the entries up here filled out, we'll be able to fill out all of these down here without doing any work. And similarly, using symmetry, we'll be able to get all of the entries down here filled out. Now, the big picture thing that I want to show you now is notice what's going on here. Right? Here we have okay, so first of all, looking at this graph, right, or looking at this adjacency matrix, A squared minus D, we see that it is block diagonal. Block diagonal. And remember, block diagonal implies disconnected. So we know that this graph that this adjacency matrix defines is disconnected. And that there are two disconnected pieces. We have the disconnected piece A1 and the disconnected piece A2. Now I know what you might be saying. You might be saying, hey, there's a 2 there. And I thought an adjacency matrix only had zeros and ones in it. And so what I need to say about that is that in our class, our adjacency matrices have just told about edges. So they've only told whether an edge exists or not. But often in applications, we use other numbers as well. If there's a 0, that means there's no edge. But if there is not, but if there's any number that's not a 0, then that means there's an edge, and whatever number that is, we consider a weight. And so this 2 right here, that indicates that not only is there an edge between W1 and W2 in the graph defined by A squared, 2 edge walks, but it also means that there's more weight given to this relationship between W1 and W2. So because there's a higher weight between the edge between W1 and W2, that means that it's a higher likelihood that W1 and W2 occur in the same sentence. And in fact, in our example, if you go back to part A, you'll see that in fact word 1 and word 2 do occur in the same sentence.